September 11th, combining like terms. Nearly every problem in Algebra 2, and a lot of problems in Algebra 1, include the step combine like terms. This is a lot easier when you take the time to remember what like terms actually are. For any two terms to be considered like terms, both of the following must be true. They have the same exact variables and the same exponents. If both of these conditions aren't met, then they're not like terms and you cannot combine them. So class example, sort each of the following into groups of like terms and then add all of the listed terms together. Which order should I do this in? There are x's, x cubed, y's, so on and so forth. There's a convention of math to answer this very question. What you do is you start with the highest exponent and you work your way down. Our largest exponent in this table is a 3. The only term that has that exponent is 8x cubed. There is no other term that has an x for the variable and a 3 as the exponent, so we just copy it straight down like this. Next, I have circled all of the terms that have an exponent of 2. Notice these 3 in red have an x for my variable, and this one term in green has a y. If we consider our x squared terms, when we want to combine them, we just add the coefficients. Negative 2, which comes right in front of x squared, a positive 1, when there is no number in front of a variable, that means there's a coefficient of 1, even though it's invisible, and minus 11, which comes from minus 11x squared. Combining these three gives us a negative 12x squared, which we can rewrite over here. For my green term, there's nothing to combine, there's only 1, so I copy down plus 2y squared. Next up, I have circled all of my x terms in pink, and I wrote out the coefficients down here at the bottom. The reason why we do the x terms next is because all of the variables have an invisible degree or exponent of 1. Within all of the exponents of 1, we will proceed in alphabetical order. So 3 plus 1 is 4, minus 5 negative 1, plus 6 is 5, plus 5 is 10, plus 3 is 13. We can write this as plus 13x. Next up, in brown, I will circle my only xy term, and we copy that down. There's nothing to combine with it. In lime green, here are my y terms. There are 4 of them. I add together the coefficients. 4 minus 2 plus 2 plus 5. A shortcut, instead of adding each one separately, is to look for two terms that cancel out. For example, negative 2 and positive 2 are just going to cancel out. So really my question is, what is 4 plus 5? And that's 9. I add plus 9y to the problem. And now I'm going to look for my z terms. There are only 2 of them, and I'll do it in this teal color. 1/2 plus 1. Adding fractions can be tricky. We have to have two fractions with the same denominator. An easy way to make that happen is to convert this 1 into 2 over 2, which is another version of 1. Now both of my fractions are halves. I can add the top straight across and get 3 over 2. What's my variable? A z. So I'll write that as plus 3 halves z. And the only term left are my constants, or just my number. Sometimes we say that these have an exponent of 0. I'll circle these in orange, and there are 3 of them. Negative 8 plus 12 plus 21. Together this gives me a 25. So all together, this polynomial reads 8x cubed minus 12x squared plus 2y squared plus 13x plus 5y plus 9y plus 3 halves z plus 25. And that is the most simplified version we can come up with. Another technique to combine like terms is to list out every possible term within the expression and then write the coefficients beneath those terms. For example, for x cubed, there is one term, and the coefficient is 4. For x squared, there are two coefficients, positive 11 and negative 2. I have 7 different x terms. If I write down all of the coefficients, negative 5, positive 3, positive 6, positive 8, negative 11, positive 5, and positive 4. I have 3 different y terms, a negative 2, a positive 3, and a negative 3. Lastly, my constants. There is a 2, a 17, and a negative 1. If I want to combine these like terms, I can simply add these columns straight down and rewrite in terms of the variables. This gives me 4x cubed, 11 minus 2, which is 9x squared, minus 5 plus 3 plus 6 plus 8 minus 11 plus 5 plus 4, which gives me a positive 10x, negative 2 plus 3 minus 3, which gives me a minus 2y, and for my numbers, 2 plus 17 minus 1, which gives me plus 18. And that is my final answer. We will do one final practice problem from the back of this worksheet. Simplify each of the following by combining like terms. Let's begin with the largest exponent. That's the x squared term. What are some of the coefficients that I can combine together? Just the 1, just the 2 from here. So I'll write that as 2x squared. Next, I will consider my x terms. These have a degree of 1, or an exponent of 1, and alphabetically that's the very first one. My coefficients are 2 plus 8 plus 2 minus 6 plus 4. This gives me a total of 10, so I can write down this term as plus 10x. My y term also has a degree of 1. What are the options, or what are the coefficients? There's a 4, there's a minus 4, there's a minus 2, and that's it. These two cancel out, and negative 2 is my y term. Lastly, I have my constants, negative 3, minus 5, and plus 10. When I combine these, I'll get a positive 2. I'll write that in like here. Final answer, 2x squared plus 10x minus 2y plus 2.